Hi, it's Mr. Blystone, and here we are with the second video in Unit 1 of Geometry, and we're talking about locations as points. So this is an old school type road map of the US that gave travel times and distances between different cities. So if you wanted to get, let's say, from, somewhere like Las Vegas to North Platte, you could use these lines, you could total up the distances and the times, and you could get a basic travel time between those two cities. Now, let's say we wanted to go from New York, which is way over here, to Los Angeles right here. How long would it take us? Well, I use Google Maps now, and it says one route to get there is 2,776 miles. That's one route that we could use to get there. Now, another says the air distance is about 2,400 miles, between 2,400 and 2,500 miles. How are these different? Why are these different? Aren't they the two same cities? And then another route gives a different distance between New York and Los Angeles. Well, we've got to consider a few things. Where do we start measuring? Do we start right in the middle here? Do we start there? Do we start at the coast? Do we start at this end? Do we start where? And again, in New York City is a big area. Do we start in the middle of downtown Manhattan, perhaps? Which would be somewhere here, where I can't see my mouse, but you can see it. Or do we start somewhere else? Where do we start with this? It's kind of vague. We don't know. And it depends on the highways you take. You might get a shortcut here and a longer route going that way. One route might be faster in time and one might be faster in distance. One highway may cut off a few miles and one may add a few more. So it's relative, just depends. Well, let's take a look at another kind of interesting idea. Here I have a line with two big dots on the end and a ruler. This is not to scale. This is just a picture of a ruler that I got. It's probably not exactly right. But how would you measure this? And this is an interesting activity. If you have a ruler and some people to try it and see the measurements you get. But interesting things happen. So one person might grab the ruler and say, okay, I'm going to measure. So they go to the center of the dot, and they go back to the center of the dot, and with this ruler, it's a little over 12 inches because it's the whole ruler, which it doesn't actually start here, so it's about there. Now, obviously, that may not be correct to size, but I'm just giving you an example. Another person might say, oh, you want the line. So they're going to put the thing right at the beginning of the line, and they're going to say, oh, well, the line is just about 11 inches. And one person is going to take and say, oh, well, it's the whole thing. Okay, we start here. Well, from there it's 12 inches, and then they're going to put a finger, and then they're going to basically take and, whoops, what did we do here? Sorry about that. And they're going to move it over, and then they're going to measure a little more, and they're going to say, well, that's another inch, so it's about 13 inches. So everyone's going to kind of do it a little bit differently. You just said measure it. You didn't say exactly where to start, you just said measure. And everyone's going to have a different idea. So it's kind of a little bit different for everyone. Are they correct? Yeah, they've measured it and they've shown how they do it. So they're correct for what they're measuring, assuming they know how to use a ruler, but they're each a little bit different. So when points are described as exact locations, we call it synthetic geometry. In the last video, we talked about discrete geometry, points as dots. Now we're going to talk about synthetic geometry, points as exact locations. So here are some descriptions for synthetic geometry that you should probably pause the video and write down. A point is an exact location. A line is a set of points extending in both directions, containing the shortest distance between any 2 points on it. So, let's look at a few more definitions. Number lines. You've seen number lines in probably earlier courses when graphing things like inequalities and things like that, and seeing where numbers lie. So a number line is a line with points that are numbered. Every number identifies a point, and every point is identified by exactly one number. A coordinate is the number that identifies a point. A coordinated line is a line with coordinates. And the density is the property that says that between any 2 points on a number line, there are infinitely many points. We can think about that in the way that between, for instance, 0 and 1, we have, we could have 0.000000001, and we could go up by that much each time, or we could go by even smaller. So there's infinitely many points. And between those 2 points, the 0 and 0.5 zeros and a 1, there's infinitely many more. We could just keep going and add zeros before a 1 and make it that small. So there's infinitely many points. A number line is dense. So here's a number line. We got 2 points, B and A. In this case, B is at -1, A is at 3. So, a few more definitions. The distance between 2 points on a coordinated line is the absolute value of the difference of their coordinates. So basically, we take the 2 coordinates, subtract them, and we take the absolute value. The absolute value is just the value. We don't worry about the sign. In symbols, if they're x and y, we say the absolute value of x minus y. And if we're using AB, the distance is written AB. That's how we show the distance. So let's look at an example. Find AB on the number line. All right. So what we would do, we'd say, okay, A, we look, is 3. And B equals -1. So we know it's the absolute value of B, which is -1 minus 3. -1 minus 3, well, that's -1 plus -3, which is the absolute value of -4, which is 4. That's the distance. Now, what if you got it backwards and said, whoops, I did A before B? What if you did that? Let's just see what happens. If I put A first, 3 minus -1. Minus a minus becomes plus a positive. And we're left with 3 plus 1 is 4. The absolute value of 4 is 4. Same. It does not matter which order you do 2 points for this. For the distance on a number line, it doesn't matter. The absolute value cancels it out. It will be the same either way. On a number line, the distance between 2 points, whether you start with the highest number or the lowest number, it works. All right. Here's one for you to try. Find the following distances on the number line. We have CD, AD, and BC. Not all of them are numbered, so you may have to kind of think about it a little bit. So pause the video, see what you can do, then restart it, and I'll give you an answer. See if you did it right. Okay, you've had time to pause the video and work it, so here we go. For letter A. Let me make this line. Can I go a little thinner? Yes, I can. All right. So we said CD. So if we look, each line, well, between 0 and 1, there's one line. So this must be 1/2. Each goes up by 1/2. So this is 1/2, or we could say 1.5. We might want to use decimals. Some people like decimals over fractions. I can take it either way. So CD. So we have CD is the absolute value of 2 minus 1.5. 2 minus 1.5 is the absolute value of 0.5, which is equal to 0.5. You could have also said 1/2. Same. All right, for B. A to D. Again, we know D is to A, so let's count. This is -1/2. So there's -1, -1.5, -2. So A is -2, D is 2. So 2 minus a -2 is equal to, well, 2 minus a negative is plus a positive. It's absolute value of 4. So the answer is 4. Last one, B, C. B, we've already written here, -1/2. C is 1.5 or 1.5. So we'll call this -0.5 instead to make it easier. So 1.5 minus a -0.5. Some people like 0.5 to help. That changes it to plus a positive. So 1.5 plus another half is equal to absolute value of 2, which is equal to 2. That's the distances. Hope you got this one right. All right. So again, as I said, because the property is of absolute value, if you switch the order of the points, the distance will be the same. So for any 2 points AB, A and B, AB equals BA. You can do it either way. So there was an example. Here are some problems to try if you're following along with the book. 4 through 11, numbers 14, 15, and 18. Hope this video helps, and as always, keep learning.